Hello, everybody. Welcome to Paradigm Conference. It's so nice to see you here. My name is Maria Delgado, and I'm from Spain. I will be teaching you APL with my friend Rohan, as I am your APL lead. And in today's session, we're going to get started and solve the first problem of the Dialogue APL problem solving competition of the year 2009. So let's move on. Let me share my screen. The plan that we're going to follow is we're going to try and understand the problem. We're going to understand the basis of the problem, then we're going to think how can we develop it in APL, and then we will try to do it in APL. Okay, so here we have the problem. As you can see, it's called multiples of 3 and 5. Remember that you can find it in Dialogue APL problem solving competition. I will show you later how you can find it. Okay, so let's read it and try to understand it. If we list all the natural numbers below 10 that are multiples of 3 or 5, we get 3, 5, 6, and 9. The sum of these multiples is 23. Find the sum of all the multiples of 3 or 5 below 1000. Okay, so I think we can first try to understand the first paragraph and then move to the second paragraph. By the first paragraph, I mean this part, we can use the highlighter to highlight all the important information that we can find here. So maybe we have natural numbers. We all know that natural numbers are 1, 2, 3, 4, 5, etc. We also have below 10. Below 10 means that, for example, let's say number called n is equal or less than 9. It cannot be 10. And we also have this important information that is multiples of 3 or 5. We know that the multiples of 3 or 5, or multiples of a number, in this case, we're going to get 3 or 5. It's the number multiplied by n, being n in natural numbers. And in this case, the multiplication cannot exceed 10. So it needs to be below 10. Okay, so the multiples of 3 in this case, the multiples of 3 in this case is 3 times 1, 3 times 2, and 3 times 3. That's equal to 3, 6, and 9. 3 times 4, it's not multiples of 3 that is into this part of the paragraph because it is higher than 10. And the multiples of 5 will only be 5 because the next multiple, that is 5 times 2, it's equal to 10, and we need numbers below 10. Okay, so it says that the sum of the multiples is 23. So let's see, 3 plus 5 plus 6 plus 9, it's 23. Okay, so it's correct. So let's try to move to the second paragraph. Find the sum of all the multiples of 3 or 5 below 1000. Okay, so how can we do it? That's an important question. But we can try and divide, we can do the multiples of 3 in one part and the multiples of 5 in another part. So let's put here, for example, the multiples of 3, and here, and here the multiples of 5. Okay, so we have explained that the multiples of 3 are 3 times n, being n in natural numbers. In this case, 3 times n needs to be lower than 1000. And in the part of the 5, the multiples of 5, we have the same, 5 times n and natural numbers, and the multiplication itself needs to be lower than 1000. Okay, so we need to find that n. We have two possibilities. We can do like that inequality, but we're going to use this method that is an integer division. So we will have a reminder. Let me explain it while I'm doing it. Okay, so let's first take a look at the multiples of 3. We're here. So if we're going to try and find that n, because it will give us the maximum amount, we can do 1000 divided by 3. It's an integer division, so it will be 333, and we have 1 as a remainder. This 333 is the actual n, because you can do the division, but 3 times that number is 999, and 999 is less than 1000. And we can do the same with the multiples of 5, but we will find a problem. Let's take a look. 1000 divided by 5, it's equal to 200, and we have 0 as a remainder. So what can we do here? We can just subtract 1 from this n that we have found. It's like 200 minus 1, it's 199, and 5 times 199, it's equal to 995, and 995 is it's below 1000, and it's the highest multiple that we can get below 1000, because the other one, that is 5 times 200, 5 times 200 is equal to the actual maximum that we can get, that is 1000. Okay, so we have found the maximum n's. For 3, we have this n is equal to 3033, and for 5, we have 199. Okay, so how can we follow with this problem? Because yes, we have done a little bit, but we need to do the other part, because we need to find all the sum. It's the whole sum. The sum of the multiples of 3, in this case, will be 3 times 1 plus 3 times 2 plus 3 times 3, etc., until 3 times 333. But this is the step that we're going to do in APL. And in the case of the multiples of 5, it's the same, but with n being 199. So it's 5 times 1 plus 5 times 2, etc., plus 5 times 199. This is the sum of 5, and this is the sum of 3. And what we need to do with this result, like the result of this and the result of this, we need to, yeah, it's easy to understand. We need to sum the sums. So it's the sum of 3 plus the sum of 5. How can we do this in APL? We're going to do it in the computer later, but I want to think of it in a paper in some way, so we can start our critical thinking. We know that in APL we can create long lists with iota. We know that iota is this. So for example, iota 5 will create a list of 1, 2, 3, 4, 5 elements. But we need to create like the list of elements that are the multiples of a number. Let's take a look with the multiples of 3 in this case. So how can we do it to create the list of the multiples of 3 in APL? Well, we know that we are going to get 333 values in this line, in this vector. So it will be iota, iota 333. And we need to multiply it by 3 because it will give us our multiples. I mean, if we just did iota 333, we will get 1, 2, 3, etc. 333. But if we multiply it 3 times iota 333, we will get 1 times 3, 2 times 3, etc. That it will be the actual multiples of 3, so it's 3, 6, 9, etc. 999, and that's what we want to. In the multiples of 5, we need to do the same. So it's iota 199 in this case, to get 199 values, and we need to multiply them, each one of them, by 5. So we put 5 on the sign of multiplication. So let me erase this so we can get more space. We said there is 3 times iota 333. But we need to sum of the values. If we remember, in APL, we have the plus reduction. That is this thing that we are seeing here, that it sums all the values in the vector. So if we do it, let's put an example and then we will do it. If we have iota 5 and we do the plus reduction, we will get the sum of all the values inside of the iota 5. So it's 1 plus 2 plus 3 plus 4 plus 5, but we won't need to put all the some signs. It just makes our work easier. So what we need to do is to put the plus reduction inside of this, of the things that we just done. So for easy understanding, we could use parentheses, but it's not necessary. Okay, so we put the plus reduction and the plus reduction, and we can use other parentheses. And if we see here, this is actually the sum, and this sum. So what we need to do right now is just to sum this with the sum sign. So we need to take it out in our APL. So let me share my screen in the computer. Let's see if I can find it. Okay, so I think that you're looking at my screen right now. Okay, so this is a actual problem in the PDF. Okay, so we're going to use try IPL. We can do it like this. We've said that we're going to use parentheses so we can understand it better. So we're going to put parentheses. We're going to use the plus reduction. We're going to use another parenthesis to understand it better. We're going to multiply by 3 because we're trying to find in this part the multiples of 3. Remember that the multiplication, we need to, for the multiplication, we need to put this sign because it's the multiplication, not this one, because this is the exponential one. We need to do the iota to generate the list, and we have 333 members, values in that list. And let's close this parenthesis and let's close the other one. Let's do the sum, and let's do the same, but with the other one. With this, I mean the multiples of 5. So I've added the plus reduction, let's set the other parentheses for easy understanding. Let's set the 5 because we're trying to find the multiples of 5. Let's add this multiplication sign. Let's put the iota to generate the list. And we have 199 members, values in the vector in our list. And let's close all the parentheses. So let's see. And it gives us the actual sum of all the multiples of 3 or 5 below 1000. So this is the solution. You can check it in your calculator, you know, another programming language, but APL is so cool to do this. If you want to look for this problem, you can go to dialogue.com. You can click on learning APL problem solving competition. You can scroll down and in the year 2009, you have the PDF here. And you can see that this problem was actually from Project Euler, and we've solved it in APL. So thank you so much for staying with me. And I hope you have enjoyed this video. I hope you have, I have explained myself great and hope you understand it. And let's see if we can get more people interested in APL. I will see your comments below and thanks so much. Bye.